It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to solve problems on continuity. Our problem here is we have a rectangular field is to be enclosed with 300 meters of fencing material. If we let x be the length of the field, express its area in square meters in terms of x. Identify the domain of the function representing the area and show that it is continuous on its domain. So our problem here is asking us to identify the domain or the values of your x in which the function is representing the area with. And we are to show that it is continuous on that particular values of x. So how to do this? We need to look for the value of our x. But first, let's try to understand the problem here. According to the problem, we have a rectangular field which is to be enclosed. The word enclosed here, this will be our keyword that what we're having here as a measurement, which is 300 meters of fencing material, is what we're having as the perimeter. So our perimeter here is 300 meters. Now, upon having that particular given, we are now going to identify what will be our dimension, because we're having here a rectangular field. So out from there, we would know that if we've got a perimeter, that means to say that if we have this rectangular field, our perimeter, we can represent the dimension here as this could be our x and this could be our y, because according to that one, if we let x be the length of the field, express its area in square meters in terms of x. So we have the length is x and then we have the height as y. Now, since we are asked for the area, let's go back for the perimeter here. We know already what is the formula for perimeter. Once we're having a rectangular field here, perimeter is equal to 2L, or twice the length. Our length here is x plus twice the width or the height here. So we have that one as 2y. Now, once we have that, we can plug in our perimeter value, which is 300 meters. So I'll be getting only the 300 without the units, so that there won't be any unnecessary symbol there that will be needed on the computation later on. So we have 300 equal to 2x plus 2y. That will be our first equation. Now, we are asked to find the value or express the area in square meters in terms of x. So our area of a rectangle is equal to length times the width, or length here, take note, we let our length be the x. So we have x times the y. We don't have the value for the area, so let's just have it as our a. And then after this one, we are going to look for, because it says here, express its area in square meters in terms of x. So meaning to say, we cannot see any other value there aside from x. We have the variable y here. Sorry, I said value. That should be a variable. So we cannot have any other variable here aside from x. So our y here, we are going to express that one into, or in terms of x. So from the perimeter equation, we are going to solve for our y, noticing that everything here is divisible by 2. So we will be dividing this one by 2 to simplify our equation. So we have that 300 divided by 2 is 150. And then that will be equal to an x plus y. So out from there, we can now come up with our y. We just simply try to transfer our x by simply subtracting an x here and also on the other side. So this will become 150 minus x. That will be equal to a y. So we have now the y here. So let's try to plug in our y. We have a equal to x will still be there. Our y will be replaced by 150 minus x. Now do not bother distributing our x here, because what we're aiming here is to solve for x. Now the next step is for us to let our area be equal to 0, because what we are going to look for are the values of x that would make somehow our area into a minimum value as an area, which is a 0. So this one here, our area is 0, and then our x times 150 minus x. We're solving for x, so right after this one, since this is expressed by factors, we are going to equate our factors. So we have now x, that will be equated to a 0. And the other one is the 150 minus x will be equated to a 0 as well. Now for 150 minus x, if we try to move our x to the other side, because we're solving for x, we're adding x here and also on the other side, we have this one as 150 equal to an x. So meaning to say, our possible values of our x could be ranging from a 0 up to 150. We may include the 0 and also the 150. Now, this one is an interval because we are having here the values of x. Meaning to say, this interval from 0 up to 150 of your x are part of the domain of your function. Meaning to say, if you try to get values within 0 to 150, your function will still be okay. You'll be getting a value of your y there. But if you get values that are outside this interval, your function will not be okay, because you will be getting an area which is a negative. So that is why we're having this as a domain, because these are the only values of your x in which it will be giving you an area which is from 0 and the positive areas. Now, the next step is for us to show that it is continuous on its domain. Now go back to proving this one as continuous on an interval. So let's try to recall that one. But since if you try to look at the area here, the function of the area is a polynomial. And under polynomial, we do not have any problem at all. You will not have a discontinuous function in there. Meaning to say, upon showing that it is continuous on its domain, you may simply say that this is a polynomial function, and polynomial function is continuous in nature. So any interval would do as long as it is polynomial function. You have that interval as continuous on that particular polynomial function.